participant. 一二三四五。
Josie. Hello, everyone. Good evening.
Oh, gee.
Okay, I see people are still entering the Zoom. Let's give another couple of minutes, then we'll start. I hope everyone is having a great weekend. It's raining outside here in Houston. I will mute everyone, okay? Okay, let's just start. Oops, Nathan enters. Okay, hello everyone. My name is Jinda Watley. I am the founder of Avi Climbers, and I'm a private college counselor. So can you guys see me? Somehow I don't see myself. Can anybody chat me?
Yes, we can hear you.
Okay, thank you so much, Felicia. Okay, so by the way, Felicia, job well done today. Congratulations. So anyway, welcome to tonight's seminar. I invited an expert from the aviation world and to come to share his expertise and what he knows to share with the young people, what's the job opportunities in the future. Because, what we do in my educational group is what I basically share his expertise and what he knows to share with the young people, what's the job opportunity. Let me do something. It is my, I need to turn off the Zoom. Let's see the sound. Let's see, where do I go? Okay. This time it's going to work. Okay. So there's always a catch. There's a YouTube is talking, and there is somebody just entered. Okay. So back to where I was. There was a glitch. So the Ivy Climbers will provide educational academic courses to the gifted community, right? I have a strong belief is I would like to all my students and all the students in my community to study ahead so that they're mentally challenged, they become stronger students. And I also, my main focus of my work is to help high school students to support them and to follow their interest, to identify their talent, and then to provide learning opportunities, such as this evening's event, so that they get to know what's available to them. That's my job. And So also we help the high school seniors to apply for universities, by the time they graduate from high school. So every year during the college application season, which is right now, I often meet students who have no idea what they want to go to college to study and what's their future major or what's their future career, which is I'm not surprised, because if the students just go to school and take courses and get A's and B's and C's, and then participate in the sports activities and study some music, and I'm not surprised if the kids don't know what they want to do in the future, right? They just haven't explored enough and not enough deep learning, so that it's very hard to make a decision based on what they know. So that's why I invited Mr. Curtis to come to talk to you and to show you, to teach you guys what he knows. And maybe, you will get a point or two from him, and that will help you to think and make decisions, right? So let's welcome Mr. Curtis. Let's see. So Li Hao, why do you ask me to turn on the AI companion features? I will, because Li Hao is a smart guy. No one has asked me to do that yet. Okay, so David, I'm going to hand the meeting to you, and many of the people here are my students, and I see their names and all that. So you can share your screen now.
Okay. And can everybody see that?
Yep.
Hi, hello, my name is David Curtis. Can you hear me? Okay.
Yes.
Okay. I'm actually coming to you from southern Louisiana. We're out on a fishing camp, and so if you hear some hungry fishermen in the background, we had a long day today. So don't be alarmed if there's a little bit of noise in the background. So just a tiny bit of my background. I started flying when I was 14 years old, so I've been in aviation for quite a number of years. And I started flying with general aviation airplanes, and I had a career at Boeing in the training department in technical systems training and courseware development. And then I went into pilot training. And from the pilot training, I went to fly a Boeing 767 worldwide. So it was a very unique experience in that I was basically on a 767 teaching systems and then pilots and then flying it for probably 30 years. So it's a kind of not a really common thing to be able to do something like that. As we'll get into a little bit later, the most pilots, if you're a pilot, switch jobs as far as airplanes quite frequently. And I wanted to share with you also, because I worked for Boeing, a lot of the opportunities that are in aerospace. I had a couple of things I wanted to talk about first, though, and just about how you might approach a career in a general sense, irrespective of aerospace or anything else. I really enjoy aerospace, and one of the reasons you may want to get into aerospace is because you might think it's a fun area to be involved in. Space exploration, flying airplanes, a lot of cutting edge technology. So if that excites you, you can do some of the similar jobs that you could in other industries, but you can do that within aerospace. So it basically has everything, and it can be very satisfying career. I will also mention that what I'm doing now is for as a presentation is basically suggestions. You're taking charge of your career, and I suggest that you continually change and evolve your path, because everybody's different, and the landscape of the job is very different, and it's changing very rapidly, just like everything else. AI is a very good example. That has a big impact on all aspects of aviation. So I think that this is just to kind of whet your appetite and start your your path. And we'll keep this very informal. If you have any questions, we'll just kind of go through a few things and start talking, and you can chime in at any time, and we'll just talk about it as we go along here. Okay, so the first thing we want to talk just a little bit about in a general sense is our methodology or our approach to a career, going through starting from college and then maybe into internships and into a career. So having a plan is a very good idea. And I was asked this question quite a bit when I was younger, like, what do I want to be when I grow up? And oddly enough, I didn't really know the answer. And I just said, because I started flying when I was young, I said, oh, I guess I'll be a pilot. And I really didn't put much thought of that. In fact, I was an actuarial student for a while, and I was in investments and insurance for a while, and ended up back as a pilot. So I guess my premonition was pretty accurate there. But don't worry about, like Jingda said, don't worry about not knowing what you want to do, because it is things change so fast, and you might switch careers several times, and then again you may be the kind of a person who knows what they want to do and really focuses and zeroes in, and both paths are very acceptable, and you should optimize according to kind of how you feel and how you want to approach things. But my point is that diversity can be a very good thing, especially with the way the world is going. The more kinds of different crafts and trades, the more tools that you acquire, the better you're able to adapt to a rapidly changing world. And so you may want to go into college and start one thing and then end up doing another thing. But it all should come together if you keep following your nose. So just wanted to, before again, the talking about aerospace, as looking back at a career, I've noticed that life is really a mix of timing, luck, preparation, choices, perseverance. Things are changing as you go, and a lot of people end up doing something they never even planned on doing. So I think a good approach is to think probabilistic. You want to make decisions that increase your chances of getting to your objective, because it's very hard to zero in on and keep it just at one thing if you just are always making decisions that give you the best opportunity for getting to what you want to do, and leaving your options open. Or sometimes you might want to nail down an opportunity and really focus. And so I think that you just need to always understand that you're continuing the road with less than perfect information. It's not like you just say, I'm going to be this, and then it goes that way. And before I wanted to mention also that, and I'll say this again, it's a long road and an exciting road, but you're going to have some setbacks. And so, for instance, if you don't get into the right university, or you don't get the right internship, that doesn't matter really in the big picture. As long as you keep going, there's going to be, you don't win a game on one shot, or you don't win your career on one opportunity. Just keep going, and then look at your opportunities from that point on. So I think that kind of an attitude will really do you well. Also, life is a balance of going with the flow at times and focusing at times. So sometimes the opportunities or something you might not have, you want to keep yourself open to opportunities that you might not have thought about. Sometimes you want to really persevere and lock down on something, and that also has to do with your personality. So do you want to specialize? You want to combine disciplines? And what I found, and my father actually told me this when I was younger. He said he was an actuary, and he said that most of the actuaries in his company were a lot smarter than he was. But what he was a marketing type person. He was a sales type person, and he went through the actuarial technical side, and so he ended up with the people skills combined with the technical skills. So sometimes combining a general skill like finance or marketing or sales along with a technical skill will put you in an area that there are less competition, and you may find that you have opportunities there. And then again, you may really enjoy doing one thing and specializing in the technical side or the people side. So these are things that you have to kind of think about as you go along. But one thing is that if you're always learning, I think you're never going to fall behind. So now let's take a look and start to look at what aerospace is. So aerospace really is about designing and manufacturing aircraft, spacecraft, and the related systems. It's divided into two major sectors. There's aeronautics and astronautics. And excuse me, this presentation is part of it's not exactly designed for a web presentation like this. It's actually an interactive CBT. And if you're interested in these kinds of things, and we might develop some more like mathematical oriented careers and some current topics or whatever. But let Jingden know if you would like to take some of these courses and have interest in them, and we'll see about trying to get some up for you if you do. But this is actually one of those courses that I actually developed, and so it's like I say, not optimized for this type of presentation. So aeronautics deals with airplanes and atmospheric flight. So basically, you have drag, air, and the airplanes are flying through the air, and the aeronautics is the whole area of airplanes in the atmosphere, where astronautics focuses on spacecraft and exploration beyond Earth's atmosphere. So whole different set of rules and whole different environment that you're operating in. So those are the two areas of aerospace. So some of the things that are really, I think, amazing in the aerospace career is that you get a lot of cutting edge technology, innovation. There's a lot of focus on groundbreaking projects like, space exploration. There's drones, there's electric aircraft. It really tends to be at the cutting edge. AI is really impacting it, just like everything else. Space is now opening to commercial applications, which is an exciting thing. You've got SpaceX, Blue Origin, in addition to NASA with the traditional things, you've got space with the commercial applications and things like mining. We're going to be mining minerals and things from the moon. When you launch a spacecraft, the biggest cost is actually getting it through the Earth's atmosphere. And so the thing that we'll do in the future is we'll go to some asteroid or the moon or something. We'll shoot up there and then mine our materials up in space, so we don't have to shoot them up through the atmosphere. Aerospace is global in nature, so we've got satellites, communications, transportation on a worldwide basis. There's high demand for engineers, scientists, and technologists. It's obviously, again, a very high technology, and it's relatively well paying. I will say, just like anything else, you have a relatively high average salary, but some of the salaries get very high, like in most industries. I even know that some of the aeronautical engineers have even gone into Formula One racing, and they're making in the millions for their salary. So some of this applies even to Formula One racing, this aeronautical engineering. So I don't know if we can answer. What is most people's interest? Is it piloting, engineering, just general interest in what aerospace is? Can we have any kind of feedback on what people are interested in? These are some of the career path examples here, and we'll look at them in a minute. I'm not able to see the numbers yet, but I'll just kind of press on here without that information.
I think you go ahead and speak about the pilots and stuff.
Oh, okay.
That's cool for the kids. And right now there are a lot of interests.
Oh, okay. So go light on some of the engineering type things. I'll gloss over those, and we'll talk more about the pilots here. In aerospace engineering, there are really two kinds of engineers. There's aeronautical engineers and aerospace engineers, just like aeronautical and aerospace in general. And they're basically designing the aircraft for either space or the Earth's atmosphere, and they specialize in areas such as aeronautical engineering, structural engineering, propulsion systems, avionics. A company like Airbus or Boeing would have structural engineers, aeronautical engineers, avionics, mechanical engineers, all kinds of different engineers. And one thing to keep in mind and keeping your options open is if you're thinking of going to an aerospace company like Boeing, you wouldn't necessarily want to go for a propulsion engineer job because that's more of an engine. Boeing does hire propulsion engineers, but aeronautical engineers and structural engineers, actually aeronautical engineers are the top of the heap. And you go to a company like Pratt and Whitney or Rolls-Royce, the engine manufacturers, their top engineers are the propulsion engineers, even though they have those. So just kind of have an idea early, you can save yourself some heartache down the road. Pilots and astronauts. Obviously, you know what a pilot does. They operate aircraft or spacecraft. It requires extensive training and certification. One of the difficulties is the cost to learn the piloting skills and to get certified. It requires different ratings and licenses depending on how high you go. You can get the private pilot license, commercial pilot license, and all the way up to an airline transport pilot license for aviation. But we'll talk a little bit more about that when we talk more about pilots in a moment. Aviation technicians, that's a very interesting job. If you like the mechanical aspect of things, that's a pretty fun job. And it actually is a licensed also. You get an FAA license to be an aviation technician also. Air traffic controllers is another area that's pretty fun. They're basically the guys talking to the pilots and keeping the flow of aircraft going in and out of the airports and watching the radars. And it's very, very high. It's a demanding role. And aerospace software developers. You might not have thought about this, but they're actually in vogue right now because they actually create softwares for flight control simulations. And one of the big things now is drones and autonomous airplanes. So drones might be flown from somebody on the ground, where a autonomous airplane might just actually be like the new self-driving cars and things. And that's very much currently happening right now. Some other things in aviation, there are traditional positions like sales and marketing, training, graphic design, finance, publications, and marketing for commercial airplanes. We're going to look at in just a moment here. It's a little bit different than you might have an area of job opportunities in another kind of industry. There's something special about the marketing in aviation. Training areas, I was involved in the pilot training. You can have aircraft systems training. There's human resources. There's different specialty training. So those are some other opportunities, that are among other things. Emerging aerospace fields, unmanned aerial systems, like I mentioned, drones and autonomous aircraft. Space tourism is up and coming, where actually people are paying to go up into space. Space exploration, we're going to look at a video here on CubeSats, which are a fun project that actually high school and college students can actually send things into space and have a project with. Space mining, like I mentioned earlier, shuttle operations, probes, urban air mobility. That picture to the right is actually an urban air mobility. They're developing now electrical, hydrogen-powered electrical engines, and they're going to be taxiing people to the local airport and around cities and things. And so those will be both autonomous and at the beginning here, piloted, but they'll start operation probably in the next couple of years. Sustainable aviation, focus on the sustainable fuels like hybrid aircraft, electric aircraft. Right now, they're doing a lot of burning of the ethanol and the corn in trying to reduce emissions and things. That's a very big focus right now. Believe it or not, quantum computing is big. The demand for computing for a company like Airbus or Boeing is so large that the regular computers just are running out. They're getting too limited, and they're already starting to use quantum computing in design of airplanes. So, excuse me, I'll get rid of this here. So, try and get had a notification come up here. Okay. So if you're interested in engineering, I'll go through this quickly because I know we want to get on to the pilots, but I just wanted to point out that engineers are not just an engineer, is not just an engineer. There's all kinds of different varieties of engineers. The aerospace language is engineering, and even if you're a pilot, you might want to be study engineering undergraduate, because if you wanted to work for a aerospace manufacturer and you want to be a test pilot, it requires an engineering degree because they want you to speak the language. So the engineers are interdisciplinary. They collaborate quite a bit. The structural engineers, test integration engineers are working with the aeronautical engineers, and publication engineers are writing technical manuals. When an airplane takes off, it has to have a whole set of engineering work behind it, and every time it takes off, we have to calculate the required takeoff distance, the required landing distance, the payload. We calculate different speeds for takeoff, and so all that's done and approved by the FAA, or whoever the governing body is. Aerospace engineering is focusing on the design and development of aircraft, which is we already talked about. Mechanical engineering, design analysis of mechanical systems. Engineers in this field can work on structural analysis, space structures, propulsion, all kinds of things. Electrical engineering focuses on electrical systems in the airplane, as well as electronics, power generation, and the airplanes have to generate their own power off the engine. Avionics systems, so it's communication, so that's a big field in engineering. Computer engineering, hardware and software on the airplanes, and these airplanes are need to be high reliability. So these systems are mission critical. They are approved by the governing bodies, and it's very interesting work. Systems engineering focuses kind of cross engineering. So they integrate the different systems on the airplane and make them work together. So you've got materials and science engineering, obviously composites, metals. The airplanes are made out of some pretty high-tech exotic metals and composites. Manufacturing engineering, 3D printing, production line types of things. Chemical engineering applies to the fuels, and like I was mentioning, the green, the movement with the green zero emissions eventually, and software engineering, flight software development, especially with the autonomous and the autopilot systems. It's a big area of engineering. Civil engineering, airports and hangars, infrastructures. Environmental engineering, the airplanes are flying in obviously in the sky, which is a hot topic now with the ozone layer and everything. Robotics engineering. So just you can see there's a number of areas just in engineering alone that you can specialize. Not only in engineering, finance and accounting, customer service, sales and marketing, like we mentioned. So let's look at what a typical marketing person might do that's unique to aerospace. So a marketing person would actually be familiar with the airlines and they would be assigned to different group of airlines, and they would actually do route studies and know that they need an airplane that can carry 200 people from anywhere from 400 miles to 1,200 miles, or they need an airplane that needs 600 people and they need to go 1,200 miles, right? So these marketing people reach out to the airlines, and they actually find out and work with the designers at Boeing to say this is the kind of airplane, and they might modify an airplane or they might build a whole new airplane. So they might do research to find out what the competition's doing. So these are again what they're doing, research on eco-friendly airplanes, about what that maybe that's what the customers are looking for now. They are positioning each airplane for the best solutions for the airlines. So if they have a new airplane, the marketing's helping to figure out the way to advertise it. So they're very intimately involved with the airlines in a company like Boeing or Airbus. So they build strong relationships, and they're constantly meeting with airline executives. And they're also involved in launching new aircraft after they've done these market surveys and things. So just a general marketing degree, when you get into the aerospace career, you can have a lot of fun just in this industry, I think. So let's look at a couple of current opportunities that, just as examples, that you can look forward to that are current as of now. And again, this will change pretty quickly here. There's a short video here on what's called CubeSats. And these were developed by, I think, a professor at Stanford. And he said, let's get the mass population, let's get people up into space here. Let's have a way for us to get a project up there. So we want to have some kind of a study or a little project. He created a standard box that will allow people to get space on a launch and shoot them up into space, and then the students can actually do their study here. So I'm going to play this. I hope it works here.
What is a CubeSat? CubeSats are very small spacecraft that orbit Earth. As you might guess, a CubeSat is shaped like a cube, about 4 inches wide, long, and deep. That's called 1 unit, or 1U. Small enough to hold in your hand, and very light, around 3 pounds. And like building blocks, units can be combined to make bigger CubeSats by stacking them into 2, 3, or even 6 units. Once in space, CubeSats can open up all kinds of tools: solar panels for power, communications antennas, telescopes, and more. CubeSats are great because they let schools, universities, and other teams launch their very own missions, and who knows what they'll discover. CubeSats are also made from standard, low-cost parts that are easy to get, tested for launch safety. Some NASA launches carry spacecraft that don't take up all the space on their rockets, which leaves plenty of room for tiny CubeSats. Build a CubeSat, catch a rocket ride, you become a space explorer.
Okay, another one in commercial aviation, I was talking about hydrogen and electrical engines. That's really big right now. And so you can burn hydrogen in current engines pretty much. It's just a matter of how you transport it on the airplane. And hydrogen actually can be used as a fuel cell for battery engines also. So I'll play a short video on the current hydrogen project.
Exciting day of flying, over 300 miles of flight achieved. 400 miles of flight achieved. How far did we got? 522 miles! Woo-hoo!
The team behind me is about to demonstrate something that has never been shown before: a long endurance flight on a liquid hydrogen electric propulsion aircraft that takes off and lands vertically. They have been working at this for a very long time across all aspects of the aircraft design, the fuel cell and storage architecture, as well as the development of the software and hardware that's in it. I can't wait to see it fly. The aircraft we are preparing to fly today is actually one of our pre-production prototypes that has already flown more than 25,000 miles purely on batteries. Electric is the right answer for operating air taxis in cities and suburbs. But to look at longer range regional flights, we turn to hydrogen.
With the hydrogen system, we reduce the weight of the batteries on board and add a hydrogen fuel tank designed and built by Joby, which stores up to 40 kilograms of liquid hydrogen. That hydrogen is then converted into a gas to feed the fuel cell system, which has been designed and built by the team at H2Fly.
More than 500 miles. World record. This is an incredible moment. Our goal at Joby has always been to make traveling by air as accessible, clean, and quiet as possible. Hydrogen gives us the opportunity to unlock regional journeys of up to 500 miles from city center to city center with no need to go out to an airport, no emissions except water. While the technology is still at an early stage, demonstrating our hydrogen electric aircraft will mark an important breakthrough moment for aviation that will let Joby continue to connect the world without sacrificing our future or this beautiful planet.
Okay, some exciting stuff, I think there. So, and this last video here, I just wanted to give you an example of an application that is both in military as well as commercial aviation, the technology, and that's hypersonic vehicles. Hypersonic is more than 5 times the speed of sound. So it's very fast. And military is traditionally, I mentioned earlier about the high cost to getting to be a pilot is one of the barriers. And traditionally, the military was the path in because the government paid for pilots, and most all the pilots were military. Well, that's changed over the years, and now there's other routes, and we're going to talk about those in a moment. But the military is still a viable path to learning to fly. And in fact, I spent a couple years at the United States Air Force Academy, and that's a very good path also to get in there and into to learn to fly through the Air Force, and then a lot of those people then move into the commercial airlines or corporate or something. So. In this particular example, we're talking about hypersonic vehicles, military applications. There's missiles and the counter hypersonic technologies. Civilian aircraft are actually making them for airplanes and space launch systems. So we're going to look at a couple things here, a video here on hypersonic.
There's no fixed definition of hypersonics. We generally use it in regard to flight in excess of about 5 times the speed of sound. That's Mach 5. The shock waves normally form on a supersonic aircraft are pressed very close to the aircraft. Skin friction effects in the atmosphere are so significant that the surfaces become really hot, chemical reactions become important, and you need high temperature materials with which to build a vehicle. Hypersonics has a range of applications, everything from weapons to aircraft to access to space. It's really the next step in military technology. We have relied up to now in modern warfare on stealth capabilities. Other countries are developing their own stealth capabilities. They're developing ways to penetrate stealth. Next is speed, and the combination of speed and maneuverability that hypersonic brings is going to be critical to the future of warfare.
New York to London in 90 minutes. Seattle to Tokyo, less than 3 hours. That is the promise of hypersonic travel. By now, you've probably heard of the push to bring back supersonic flight to commercial aviation. That, of course, has been nothing but a memory since the Concorde made its last commercial flight in 2003. Companies like Boom Supersonic, Boeing, and Lockheed Martin, just to name a few, are all investing in a future where passengers careen through the skies at supersonic speeds. And even though that future isn't even here yet, some are looking beyond supersonic. So today, let's talk about hypersonic travel, what it is, where it stands today, and what it could mean for the future of commercial aviation. I want to look at 3 companies that are taking on the challenge of commercial hypersonic flight and see where they stand right now. Let's start with Hermeus. The Quarter Horse is a remotely piloted demonstrator jet intended to prove the company's tech, maybe most notably its Chimera engine. Hermeus called it a turbine-based combined cycle engine. Essentially, it combines a conventional jet engine with what's known as a ramjet. That's a special type of engine that uses the aircraft's motion to draw in air for combustion. There's no moving parts. Halcyon, the company's hypersonic commercial passenger jet. Hermeus says it will carry 20 passengers and have a range of 4,600 miles. The company is hoping to have this aircraft in the air for its first test flight in 2029. Next up, Venus Aerospace, operating out of Houston, Texas. Venus hasn't said quite as much about their hypersonic vehicle. Here's what we do know. The company's catchphrase is home by dinner. The idea there is you could fly from LA to Tokyo for a business meeting and be back to LA in time for dinner. We haven't seen images or renderings of what Venus's aircraft will look like, but Venus says it will seat 12 people, fly at Mach 5 on the edge of the atmosphere, and be a zero carbon emission vehicle. The company says they'll use 2 engines, a jet engine to get the aircraft off the ground and to cruise altitude, then rocket engines take it to about Mach 9. Chinese startup Space Transportation showed us its vision. It shows passengers boarding a 12-seater aircraft linked to the belly of a rocket-like booster. The vehicle separates before pushing itself to cruising altitude in a process similar to how Virgin Galactic launches its Spaceship Two. So what we just saw was 3 very different approaches to hypersonic passenger flight. But one thing is certain, this technology is coming. It's just a matter of when.
Okay, so there you have a few different ideas. One thing I wanted to mention before I forgot here was the opportunities. One of the things that you might want to consider is whether you want to work for a big company or a small company, because there's more so than in the past. There's a lot of these startups and smaller companies. You can become a test pilot, you can get into the engineering, and you can get into the kind of the startup atmosphere with a lot of this fun technology, in addition to the traditional military, larger companies in the aerospace. Okay, really quickly, the basic kinds of things for aerospace careers: STEM type knowledge, problem solving, communication, right? Critical thinking. We won't spend a lot of time on that. Educational pathways, high school courses. If you want to get into the engineering type path, mathematics and aerospace engineering and those kinds of things. If you go in the pilot direction, down at the bottom there's certifications, and the easy way to do that is to log into the FAA, and they have a certification area, and you'll see the different licenses. But most of the certifications are required for pilots, air traffic controllers, astronauts, everything. So top universities for aerospace, and this is just some very basic ones: MIT, Stanford, Cambridge, Georgia Institute of Technology, and Caltech, not to mention that the other ones aren't good. Internships: NASA, Boeing, Airbus, Lockheed Martin, SpaceX have apprenticeships and things. So now let's get into talking about pilots. If you like to see the world, pilot's a very good, or flight attendant, even maintenance engineers. Excuse me, if you're a flight crew, you can see the world in a number of different ways. There's fixed aircraft, which is airlines, military, corporate, cargo, test, training, helicopter pilots, flight attendant. And I might mention that the careers are, you get the skill set as a pilot, you can move from airline to corporate to cargo fairly easy. But the lifestyle is very different. An airline is much more of a organized, and it has more regulated type of a area. Corporate might be, you might spend, like I was in a corporate area, we would spend a couple of weeks on the road, and we would stay in a place, in a hotel, typically in say Hong Kong or Paris or whatever, for several nights, and just kind of hang out and then go to the next place. And so that's kind of a fun way to do it. Cargo operations, you're not having to, you're flying obviously cargo, and they typically fly at night. So these different jobs within the pilots have a different lifestyle. So flight school programs outside of the military, there's basically 3 types of, or 3 paths. And the traditional flight schools, they offer comprehensive programs from pilot training to ATP. Typically, they're pretty costly. I mean, you're probably paying I don't know what it is currently, but it's, it's in the hundreds of dollars, $100, $200 an hour for flight instruction. And then you typically you would build your hours until you got enough hours to where you could get your commercial license, which means you can get paid to fly. And so now you get your flight instructor license where you can teach people to fly and maybe defray some of the costs. And so that would be the traditional path. And then airlines traditionally would not have really compensated you for all these high costs initially. It would take you several years to pay it back. Now the airlines are starting to recognize that, and starting out pilots are at a much higher salary than they did in the past, as well as they are right now is probably one of the few times in history, ever since actually I've been in aviation since the 60s on, I never seen a time like this where they're hiring pilots like this. It's a very good time if you want to become a pilot. You're in a big retiring phase of the older pilots, and they're bringing in a lot of new pilots, and they understand that the military is not training pilots, so they have to provide other programs. So universities are stepping up. And they have degree programs in aviation that include flight training. And so you can actually go to a university, some of the universities, and get a degree and come out with a pilot's license. Aviation academies are a lot run by the airlines, and they typically have some kind of an agreement that you would sign and say, okay, you're going to come out and you're going to be part of our system. So I noticed, like for an example, United and Lufthansa has an academy in the Phoenix area, and the pilots graduate from there. They pretty much got a job with United. In fact, I'll show you a video here get the United Academy here.
Aspiring pilots should choose Aviate because we have done all of the groundwork for you. You apply, interview, and then are given a conditional job offer at United Airlines. And once you've completed all your time, you transition to United without an additional interview.
I didn't have something like this when I was in college, and so we were basically on our own to make it to a mainline carrier. Now you have this opportunity where all these things are laid out in front of you, where it gives you a direct and clear pathway to a United Airlines flight deck.
You will grow up in the United culture. You'll learn from our pilots. You'll learn from our mentors.
It's essentially a golden ticket to the career of a lifetime, and we've taken all the guesswork out of it.
Okay, so just to start wrapping this up, challenges, highly competitive, rigorous education and training, very fast evolving, and space exploration careers, long-term commitment. So there's a growing demand for engineers as well as pilots. There's an increased focus on sustainable aviation, global market for aviation, like we mentioned earlier. Join STEM clubs, attend science fairs, research scholarships. You can start to go to your local airport and start to find out what kind of flight school that you might want to go to. You can work on a lot of what they call fixed FBOs, fixed base operators, and you could work as a gas guy and just start to get in the learning the craft there at the grassroots there. So really. It's an exciting time. I actually envy you guys that you have the opportunity to really start doing something like this, and I think you keep a positive attitude and just enjoy it. So with that, I'll give it back to Jingda so we can have some questions or whatever we have time left.
Wow, that's such an exciting presentation, David. It's just great. Oh, let's see. My video is not on.
Okay.
Okay, now it's better. I've learned a lot from you. I have been promoting math and science among my students, and I encourage anyone to become an engineer in the future and to be part of the technology advancement. It's just such an exciting journey. So I've learned a few engineering directions I've even never heard of, like avionics. Did I pronounce it right? Engineering and the propulsion. And that is super cool. I do have a question for you. David, you mentioned the traditional flight school, they train not only private pilots, but also ATP. What does ATP stands for?
That's an airline transport pilot. So basically, there's a number of levels, but you start out with, and they have recreational pilot, sport pilot. Those are kind of the limited license. The first license you get that you would consider a pilot license is called a private pilot. The next level is a commercial license, and that means you can get paid to fly, although a person has to hire you to pay you. So when you get enough hours, you get what's called an airline transport pilot license, which is the final license, and that allows you to fly for the public. So somebody doesn't have to. It's kind of like you get a doctor degree or something like that. So once you have that license, you're able to work for an airline or somebody that they're not. A person is not directly hiring you. And yeah, see if that's the difference there. So like you're going to somebody they have an accreditation kind of thing. Typically that takes about 1,500 hours of flying time to get that and take an exam. Outside of that, you have different ratings. So like every big jet, you have a different rating. So you have an airline transport pilot license. You have an instrument rating to fly in the clouds. You have another kind of a rating for a 767. You have another rating for a Boeing 777. You have another rating for a 737. So these are kind of like specialty expertise areas that you get a rating. And so you have a license and then you have ratings on it.
Oh, wow. Complicated. So
Yeah.
it's almost like, is there any pilot could get all the certificates to fly any kind of airplane?
Well, in general aviation, you can pretty much fly. You can fly most of the smaller airplanes. It's just basically limited by insurance. But when you are over 12,500 pounds, every single airplane you have to get a different rating for. So you can't get a license just to fly everything.
Okay.
But your license to fly is always good.
Yes, absolutely. Okay, I'm excited with there is a company, it's a Venus Aerospace is making this
Yeah, in Houston.
In Houston.
Yeah.
Where is it located? Do you know? Where
I
is
don't know where it's located. That'd be fun to check. Go visit. Maybe we
I
can
know,
do a
I know.
field trip down there.
Absolutely.
Yeah.
I think that's extremely exciting. I see there are some in the chat message, there are questions.
Okay.
Let's see. Can you click on the chat?
Let's see. I'll try and see. Oh yeah. Okay, I got it. Oh no, now sorry about I'm technologically challenged here. It's okay. Okay, the first question to Angela, I don't know the exact answer. It depends on the situation. The FAA has, I think it's called, the FAA has a medical department. And if you like, I can pass that through Jingda. But if you say FAA medical, they handle that. And they have a lot of waivers. They have certain things like, we used to not be able to wear glasses, but we have a workaround now. So it's fine to wear glasses if you have a second pair in the cockpit with you. And so depending on the type of thing, it's very possible that they can fly no problem at all. They maybe have to have a backup battery, or certain things are approved and some things are not. So I would check with the FAA medical on that. And they have certain doctors who are FAA medical doctors. And if you go in the phone book and you look up FAA medical, you can probably ask that question right to to a medical doctor that gives because you have to have a medical license for your to fly. You have to renew it every either year or 2 years. Okay. Going to Aviate would probably be faster than a flight school because they pretty much focus you, kind of fast track you through all the things to get you right in the airline. So it would be a little bit more limiting. So you'd have a broader background going to a university and then getting other things and then and getting getting your pilot license on the side. But that being said, going to a place like United would be tailored right for their procedures, their culture, and they would fast track you right in. And also, I might mention that the FAA is now in the approval process to allow an ATP license for less than 1,500 hours based on the individual airlines program of progressing first officers into the right seat before they have the airline transport. So that's definitely faster, I would say, at the airline academies, but and focused directly just to get you in the seat and going. Okay, let's see. Typically, how long would the academies are you if you talk about the academies like the Air Force Academy and those are 4-year colleges, so that you get a 4-year degree at the academies. And I'm not sure on I'm guessing it's probably a couple years. Don't quote me on this, but I'm thinking it's more like a couple years on the United academies and the individual airline academies. They take you through the different levels. So you'd first get a private pilots and then you'd move right on into some of the higher level things because you're not really focusing on flying general aviation. They're taking you right into the jets and their systems. So that's why they're a little bit fast. I'm not sure the cost. That's something you could look up. Look up the airline academies, Aviate, and that would be something that you could probably find out pretty quickly. Internships. I don't know as far as internships for high school students. I think most of the internships are for when you get into college and you go to the aerospace companies. But a lot of the pilots that I know started out in the fixed base operator. So if you go to the local airfield, like if you went to Hooks in Houston or one of the smaller airfields, they usually have the fixed base operator, and those people usually have jobs in there, and you start to learn, and they might have a deal where you can start to learn to fly a program where you're pumping gas or doing something, and they'll give you a discount. I'm not sure, but a lot of people have done that in the past to learn how to fly. Salary for air traffic control, you'd have to look at that. I think there's a website called careergrads.com. I think it's you can a couple of that, and you can put in the profession, and they'll give you the average salary, the outlook, where there's internships. So I would do a web search on those kinds of things, and don't just trust one site, but that would be what I would do to research some of this. Cochlear implants, I'm not sure if those are allowed or not. There's probably a very good chance they are. The FAA's gotten much better at working with people with different medical issues. And so I can't say one way or the other, but I would definitely not rule it out. I would check with either a FAA medical doctor or go to the website, the medical website. Okay, I think I've picked up most of the questions there. Let's see, do I miss any? Okay, what about, oh yeah, let's see, Cost Academy. Yeah, I think that's it.
Okay, there is a very persistent question here. They
Okay.
want to know, what's the salary for the air traffic control? So
Yeah.
somebody wants to be an air
Yeah,
traffic.
that's a good question. I think it's a well-paid job. I'm guessing I'm guessing it's well into the 6-figure area. And it's a pretty demanding job. They're highly skilled, and that would be something to look up in the collegegrads.com or one of those websites. That's very, very doable to do.
So I noticed there are people entered into the meeting in the last 10 minutes. So if you missed most of the seminar, I have the YouTube recording link. So I can share with everyone if you want to watch Mr. Curtis' lecture again, because it's really a fascinating. This is one of the most interesting Zoom meeting I've ever participated and learned from. Yeah, and so I think Mr. Curtis not only shared his knowledge in aviation, he also gave my students quite a few very, very practical advice. For example, we all have to anticipate the career changes, right? On Wall Street Journal, actually, the day before Halloween, there is an article is talking about because of AI. There are quite a few people lost their job already. So Harvard Business School MBA this year's applicants is 21% more than in the past years. So people are going into MBA training. So I think it looks like they should, you guys study a lot of math and science, or even not only math and science, just do whatever you're interested. And there's a lot of job opportunities in the aviation field, right, Mr. Curtis? Yeah. Okay. So thank you so much for your hard work, Mr. Curtis. And that he set a really good example what a successful executive and a pilot could be. I asked him to share a seminar, and he not only shared all this information, also he included all these animations and videos, and even more, he created a course. So whoever wants to study and can learn more. I'm really impressed, and thank you so much.
Oh, you're welcome. Glad to do it. Thank you.
Yeah, and thank you, all the kids. You guys are really good kids. Saturday evening you come to learn, and you all have a great weekend. Then I'll see everyone later.